Welcome, students. In the previous lesson, we looked at solving equations, and each of those equations contained just one variable, either x or y or z or some other variable. Today we're going to look at formulas, which are equations that have multiple variables and generally represent some relationship between multiple quantities. We're going to be looking at formulas today because I really want you to get some good practice getting comfortable with equations that have multiple variables in them. We're going to be looking at lots of situations where we have equations with multiple variables, and the more comfortable we can get with those right away, the easier they'll be to deal with when we come to them. So let's start by looking at a few examples of some formulas, and then we're going to solve each of them for a given variable. So let's look at some examples. The first example is going to be V equals LWH. The second example is going to be P equals 2L plus 2W. And the third will be A equals P plus PRT. All right. Each of these is an example of a formula. The first formula represents the volume of a box. So if we have a box, also known as a rectangular prism, with a certain length, a certain width, and a certain height, to find the volume, we take the length times the width times the height. This formula represents the volume, and it gives us the volume based on the length, the width, and the height. However, we can write this in other ways as well. And what I want to do is I want to solve this formula for H. What this means is we want to rewrite this formula, but instead of having V isolated on one side of the equation, we want H isolated. To do this, we can use the same properties of equality that we used before when we were solving equations. So I'm going to rewrite this down here, V equals LWH. Our goal here is to get H alone. Now, what's happening to the H on the right-hand side? When we write two variables next to each other like this, or three variables, this means that they're being multiplied. Writing a variable next to another variable, or a number next to a variable, without writing any operation symbol is one way that we can denote multiplication. So here, H is being multiplied by L and W. The opposite of that, to undo that, is to divide by L and W. Of course, what we do to one side of an equation, we have to do to the other side as well. So we will divide both sides by L and W. On the right-hand side, the L and the W cancel, because L divided by L is just 1, and W divided by W is just 1, so we're left with H. On the left, V divided by LW, we have to write as V over LW because we don't know what those numbers are, what those variables represent, and so we can't actually perform the division. We just have to write V over LW. This is a great answer. This is perfectly fine. Some students prefer, though, to switch the sides so that the variable they're trying to solve for is on the left. This is also fine. Either of these is a correct answer. Now what we've done here is we've solved for H, so now we know what H is in terms of V, L, and W. This might be useful if we have a rectangular prism and we know the volume that we need and we know the length and the width, but we're trying to figure out the height. Now, an example where we might need to do this, it's kind of a weird example, but there's a television show that I've seen before where really, really rich people want to have crazy aquariums in their homes or in their businesses with weird shapes and giant ones with huge fish and things like that. I can't remember the name of the show, but suppose someone wanted to put a large aquarium in their home or their office, and they knew that it needed to have a certain volume because they knew what fish they wanted to put inside of it, and they know how much water those fish need to thrive. And they also know the length and the width that they're able to use for this aquarium. They know how much floor space they have, and they know the aquarium can be 3 feet by 12 feet or something like that. And then they have to figure out what height the aquarium needs to be built at so that it has the appropriate volume, length, and width. Well, if we're given restrictions on the volume, the length, and the width, and we need to figure out what height makes that work, we can take the volume and divide it by the product of the length and the width. Having the formula written like this is helpful because in this case we're trying to figure out the height, and it tells us what to do with the volume, the length, and the width to calculate the appropriate height. All right, that's just one example. There are other examples. That's the one that comes to my mind. I hope you appreciated it. Maybe you can go watch an episode of that show and be amused or horrified at the ridiculous aquariums that people are building. Anyways, let's take a look at the next one. The next one we have P equals 2L plus 2W. Do you know what this is a formula for? It is the formula for the perimeter of a rectangle. I have not drawn the most perfect rectangle. My sides aren't completely straight, but hopefully you can tell that this is a rectangle. A rectangle is a four-sided figure that has 4 right angles or 90-degree angles. And when we have a rectangle, if we call the sides the length and the width, we know that the opposite sides are equal to each other in length or congruent. So if this has length L, then the top one also has length L. If this is width W, the other one's width W. Now the perimeter is the total distance around the outside of a shape. And if we go all the way around the outside, where we've got the length twice and the width twice, so the perimeter is twice the length plus twice the width. We could use this if we know the length and the width of a rectangle to calculate the perimeter. But I want to do something different. I want to solve this formula for W. So instead of writing what the perimeter is in terms of the length and the width, we want to write what the width is going to be in terms of the perimeter and the length. We want to get the width alone. Let's do this, and then we'll talk about why this might be useful. So I'm going to rewrite the equation down here. P equals 2L plus 2W. We want to get the W alone, so we need to get rid of this 2L term. And since it's being added to the 2W, to get rid of it, we can subtract 2L from both sides. On the right-hand side, the 2L's cancel out, leaving us with just 2W. And then on the left, we have P minus 2W. Those aren't like terms, so we can't combine them. We have to write that subtraction as P minus 2L. Now, we want to get the W alone. The W is currently being multiplied by 2, so what we can do is divide both sides by 2. There's actually 2 different ways to do this. On the left, we can just take this whole expression and put it over 2. That gives us P minus 2L over 2 equals W, because the 2's cancel. And then this is a perfectly good final answer. There's another way to write the answer, though. If when we divided both sides by 2, instead of just putting the whole left-hand side over 2, if we divided each term by 2 individually, that would give us P over 2 minus just L, because the 2's cancel out there, equals W. This is also an acceptable answer. These look different, They're written differently, but both of them express the same relationship. To figure out the width, you can take the perimeter minus twice the length and divide that result by 2, or you could take the perimeter and divide it by 2 and then subtract the length. Either way, you'll get the same answer. Now, why would we want to solve this formula for W? Well, you might want to be building a garden in your backyard, and perhaps you know how much fence you already own. So you know what the perimeter needs to be, and then you know what the length needs to be because you know the length of your yard, and you're trying to find out how wide you can make your garden so that it has the length that you need, and it also uses the amount of fencing that you have for the perimeter, and you don't have to go and buy more fencing. So that's just one example of a situation where we might want to figure out the width, knowing the perimeter and the length. We're going to do one more example now. We've got A equals P plus PRT. This is a formula that we could use when we're looking at simple interest. If you put money into a bank account and it earns interest, the amount that you end up with is equal to the principal, which is the amount that you invested, plus the principal times the interest rate times the amount of time it stays in. This expression actually represents the interest that you've earned. Now, I'm not going to write out all of these definitions, what the principal is, what the rate is, what the time is, because our goal is to not get really good at dealing with interest right now. Our goal is to just deal with formulas. So what we're going to do here is we're going to solve this formula for t. And the reason we might want to do this for t is because we might know the principal, the amount that we're investing, and the interest rate for the bank, and we might know how much we want to end up with in the end, our amount. And so by solving for t, that'll tell us how much time we need to keep our money in the bank to end up with our goal amount of money. So we want to solve this for t. I'm going to rewrite this below. Now, we want to get t alone, so we want to get this term by itself, which means we want to get rid of this one. So to get rid of that p, we're going to subtract p from both sides. That gives us a minus p equals PRT. One quick note here, if we have a variable that starts off capital, we want to keep it capitalized throughout the whole problem. And any variables that are lowercase need to stay lowercase. This is true with WebAssign. If you're given a variable that's lowercase and you write it capitalized, it will not give you credit. And the reason we want to be careful with this is because later you might see a formula that has a capital R and a lowercase r in it, or another letter where there's a capital version and a lowercase, and those two letters might represent two different variables. And so if we mix them up, then that will be a mistake. We'll be confusing two quantities. So just be careful that you are keeping your lowercase letters lowercase and capital letters capital. Now we want to get t alone. Here it's being multiplied by PR. So to undo that, we're going to divide both sides by PR. When we do that on the right, the p and the r cancel, and we're left with t. On the left, we have a minus p over PR. And so what this means is that if we want to calculate the amount of time that our investment needs to stay in the bank, we take the amount that we want minus the principal that we've invested and divide that by the product of the principal and the interest rate. All right. Please take a look at some of the example problems linked to below, so that you can get more practice solving formulas for particular variables. We won't be looking at formulas super often in this class, but we will be looking at many situations where we have more than one variable, and we want to be careful that we really understand how to work with multiple variables in those situations.